All right, so here's your first lesson. This is lesson 1.1. And I'm going to go ahead and show you what the learning targets are and then what you should be doing for this lesson. So you're obviously doing this first thing, which is watching the video, or you could have done an in-person lesson, or you can just read through the notes and see if you can do it without watching a video. That's completely up to you. Do practice for lesson 1.1 and then problems 1 and 2 in your problem set. So the learning target for this this lesson is I can classify a real number based on its properties. So what that means is we're going to look at the number system and all the different types of numbers we can have. So the first ones I want to talk about are natural and counting numbers. That's right here. The symbol for a natural number is this N with kind of 2 lines over here. And the definition is starting with 1, the numbers you count by. So think about when you were little. This is how I remember it. Your parents are teaching you, look at all the dogs or look at all the Cheerios you have, and you start by counting with 1. You always start with 1. You don't go, oh, there's 0 Cheerios and now there's 1. So I always think that's how I kind of remember natural. That's how you naturally start counting, is just with 1. The next one, so these are the elements 1, 2, 3, 4, 5, 6, things that occur in nature. So you can't have 4.5 dogs. That doesn't happen in nature. So it's really only the whole numbers that are positive and then not 0. So this is where whole numbers differ. The whole numbers can be written the symbols like this. You don't need to know the symbols as much. You just need to know the elements. So the whole numbers do include 0, and then it's the numbers you count by. So the only difference between natural and whole is that whole includes 0 and natural does not. Integers can be written with a Z, and it's got like the double line there. And these are negative and positive counting numbers and 0. So that means it's all the negative numbers, -3, -4, -5, -6, 0, and then all the positive numbers. But they're only the whole ones. They're not decimals or anything like that. Rational numbers are written with a Q with kind of a line here. And these are any numbers that can be written as a fraction. So rational numbers are 2, and I can write 2 as a fraction. I can write it as 2 over 1. 1/2, 1/3, 0 is also, I can write that as a fraction. I can write 0 over anything, 0 over 3, 0 over 4. That will still evaluate to be 0. -3 is rational, and -2.5 is rational. And it also includes decimals too. Irrational numbers are any numbers that cannot be written as a fraction, and it does not repeat or terminate. So do you see how -2.5 terminates or ends? That means it's rational. If that number went on forever, it would be irrational. And a great example of that is pi, or anything that doesn't, that's not a perfect square. So square root of 7, if you do that in your calculator, you're going to get a really long, non-repeating number. That is also irrational. Real numbers can be written with an R, and these are all the rational and irrational numbers ever. So square root of 7, it combines pretty much all of these two combinations of numbers. Whole numbers, decimals, fractions, numbers that go on forever, numbers that don't repeat, numbers that do repeat, everything. And then besides real numbers, there's imaginary numbers, which we will not talk about at all this year. You will talk about these numbers more in Algebra 2, but they can be written with a C. And again, you don't really have to memorize these numbers or these symbols. But imaginary numbers are any numbers that can be represented on a number line, that cannot be represented on a number line. So you'll learn more about this later in your math career, but it's a square root of -1. And if you do the square root of any negative number in your calculator, you'll get error. And that's because they're not real numbers, they're imaginary. So don't worry too much about imaginary numbers now. You really need to know natural through real. And you're kind of like, if you're a visual person like me, a diagram really helps you. So this is kind of how I think about it. Real numbers are every single number in the real world, okay? Irrational numbers are things that don't end and don't repeat, and they can't be turned into a fraction. So this is like pi, or the square root of 2, or any numbers that are kind of messy and irrational. Rational numbers are numbers that are fractions, decimals that end, anything like that. In the rational numbers are also integers. So integers are also rational numbers. Integers are any negative or positive numbers, whole numbers. Whole numbers are integers, but the whole numbers are limited to 0, 1, 2, 3, 4, etc. And then the natural counting numbers include all whole numbers except for 0. So rational numbers, they all, integers, whole numbers, natural counting numbers, those are all rational numbers, which are all real numbers. So there's kind of like categories within a category. And then the imaginary numbers are on the outside of the real numbers. So they just kind of hang out. They're not a part of these people here. So some examples I want to talk through, and then I have a couple of my own. So real numbers, so let's look at number 1. 3. 3 is a natural counting number. You would count like that, 1, 2, 3 when you were little. Whole numbers, it is a whole number. Integer, it is an integer. It is a negative or positive whole number. It is a positive whole number. The Q is rational, so it is rational. It ends, and it doesn't repeat, or it terminates, so it ends. And then it's a real number because it is irrational or rational. Okay, so 3 kind of has a lot of different categories there. -6 is not natural. It's not whole, but it is an integer because it's positive or negative whole number. It is rational because it can be turned into a fraction. I can do -6/1. And it is real because it's rational. Number 3, 3/4, that's a fraction, so it's not an integer because it would have to be a whole number, negative or positive, to be an integer. So this one's only a rational number or a real number. And square root of 15, that is irrational because if you put that in your calculator, it's going to be a really long number that never ends, and so that is irrational, and it's also real because it's not imaginary. Number 5 is -1.8. Because that's a decimal, it's a rational number, and it ends, so that means it's a rational and not irrational. Then it's also a real number. So then here I was asking you could name real and irrational numbers. So I named pi. You could also name square root of 2, square root of 5, anything that doesn't end or doesn't repeat. 7, I asked for a real, a rational, and an integer. So 2 is an integer. It's also rational, and it's also real. I could have named, because the most specific was integer, I could have named any negative number as well. Irrational and whole. So if you look at you can't have a number that's irrational and whole, so that one is not possible. So real quick, I want to talk through some examples, and I want to talk through where you can put them in this little diagram here. So if I go to draw, I'm just going to kind of list some numbers out here. So the first one I want to talk about is 5. So 5 is a rational number. It's an integer because it's a positive or negative. It's a whole number, and it also is what you would count with when you were little. So 5 can actually go in the most specific category there. The next one I want to talk about is 0. So the only difference between natural and whole numbers is 0. So 0 is going to actually go in the whole number, but 0 is also an integer and rational, and it's also real. The next number I'm going to talk about is -4. And -4 is not natural, it's not whole, but it is an integer because it's a whole negative or positive number. So -4 can go in that category. -4 is rational and it is real. 6.3 is the next number I want to talk about, and that one is not a negative or positive whole number, so that one's going to go in our rational. It does end, so that's what makes it rational. So 6.3 can go there. 6.3 repeating, that is also rational because it repeats. So what would make it irrational is if it never ended or it never repeated. But in this case, the repeating sign is there, so I know it's a rational number, and it's real. The next number is 3.28. 1, 4, dot, dot, dot. So the dot, dot, dots there indicate that this number is going on forever, and I don't really see a pattern here, so I can assume it doesn't repeat. So that means that number is going to go in here. It is irrational, and it is real. The last number I want to talk about is the square root of 28. If I put that in my calculator, you're going to get a really long number that doesn't repeat, so that is also irrational. So pretty much any square root that you see is irrational except for numbers like the square root of 4, because the square root of 4 is actually 2, because 2 times 2 is 4. So the square root of 4 is actually a natural counting number because you can evaluate it to be 2. Oops, I'm sorry, the square root of 4, not 2. So that is a little bit of what the real number system is. So I would advise you to ask any questions if you're unsure, but maybe start the practice and questions will arise there. So to get to the practice, you just click your practice tab and you should see here lesson 1.1 practice. Okay? Thanks for watching.